Okay, today's video is going to introduce functions and relations. We did talk a little bit last class about relations and the multiple representations of them, but now we're also going to add in functions. So the first part, a function consists of a set called the domain. So we have the domain containing numbers called the input. So your input is going to be your domain. We can also call this our x. One way to remember that is in has in in the beginning and domain has in at the end. So your domain is your input. Along with the domain, we also have a set called the range. And this contains numbers called your output. So you have your domain as your inputs and your range as your outputs, also known as your y values. So a function consists of a pairing of inputs with outputs such that each input is paired with exactly one output. Okay, so that's a little wordy and it does get a little confusing, but what the main idea is this right here. This means that for a function to be a function, or for a relation, right, a list of ordered pairs, a relation to be a function, the x value cannot repeat. And we'll look at examples, but the main thing here is that the x value does not repeat. Okay, so we're kind of talking relationships or a relation versus a function. So a relationship, so when an output has more than one, when an input has more than one output, we call it a relation. Or this is a non-function. That would mean that the x's would be repeating here. So that's why we call this a non-function or a relation. And a relation is any set of ordered pairs. So a function is a relation. It's just a special type of relation that these things are true. All right, so let's look at some examples. Example 1. We're going to identify whether the relation is a function. And if so, we have to give the domain and the range. Remember, the domain is the input and the range is the output. So let's look at number 1. So for number 1, we can look at our x's or our y's or our inputs and our outputs. Be familiar with that. So for our inputs, we have 1, 2, and 3. 1, 2, and 3, the x's do not repeat. So yes, this is a function. And the domain is going to be our output. So our domain is 1, 2, and 3. And our range is going to be our output. In this case is 2 and 4. Okay, I know that 2 x's go to okay, so the range is going to be 2 and 4. Like I said, yes, 2 x's both go to the 2, so but that's okay. We just need to list 2 once in our range. All right, let's look at the second one. Now they're giving us a list of ordered pairs, and they want to know the same thing. Is it a function? Well, let's look. We're going to look at our x values. Because the first two coordinate, or the first two ordered pairs, the x repeats, right? We have a 1 here and a 1 here. Because of that, this is not a function. Remember when we talked about the vocabulary, we said in a function the x's cannot repeat. So that makes that number 2 not a function. All right, so we're going to look at example 2, and this is where we introduce the vertical line test. So if we recall, right, a vertical line is up and down. So a relation presented by a graph is a function provided that any vertical line passes through. This needs to be no more than 1 point on the graph. Okay, so we're going to draw a vertical line, and in order for this to be a function, it could only hit the graph once. So let's look at number, what is this, number 3? Okay, we'll look at number 3. So let's draw. I'll draw a couple vertical lines. This is the vertical line test. Since all of these only hit that graph one time, yes, this is a graph of a function. All right, let's look at number 6. I'm going to leave 4 and 5 for you to do. Again, everything that is not done on this note taker during this video is your homework, and I'll be checking it in class. So let's look at number 6. Let's draw some vertical lines. Well, look, this hits the graph twice, as well as this one does too. That means no, this failed the vertical line test, so this is not a function. Again, in order for it to be a function, the vertical line can only hit the graph one time. So do 4 and 5 for homework. And look at the back page. So now we're going to start talking about function notation, right? There's scientific notation, there's function notations. You'll come across all different ways of notating these things. So in the first line, in general, we're going to have f of x, okay? And that's going to replace y. And it is read the value of f at x, or like I said, f of x. So whichever one, this one's a little bit shorter to use than the one that you're going to hear most often. It does not mean f times x. It's just saying a function in x. So f of x is called function notation. It's a function in terms of x, I'm sorry. A function in terms of x. So you're going to start to see when we were looking at equations before, we would see y equals. Well, just like it says right here, this f of x is going to replace y. So let's look at example 3. We're going to evaluate the function for the given value of the variable. So let's look at number 7. It tells us that this is our function. And it wants us to evaluate it at x equals -2. So all we're going to do is we're going to plug in -2 for x, and we're going to see what the function is. So f of x, so we can actually put f of -2 because that's what our x is going to be. And that is equal to 2 times, I'm plugging in a -2 for x, minus 3. So we have -4 minus 3, so f of -2 is equal to a -7. And if you look at this -2 is our input. We put in a -2, and our output is -7. Also, we can think domain and range. Okay, so we put in a -2, and out came a -7. All right, let's look at another example, number 10. For number 10, we have a function in terms of x, f of x, is equal to 10x plus 3. And we want to evaluate this when x is equal to -1. So we're going to find f of -1. 10 times -1 plus 3. -10 plus 3, so f of -1 is equal to a -7. So we put in a -1 and we got out a -7. All right, again, 8 and 9 are going to be left for you to do as homework. All right, towards the bottom of the page, we have graphing functions. Now this should be something that you've seen before, something that you have worked with before, but we're just going to do a reminder. Again, when we have functions, we connect the points with functions. So we're not just plotting the points like we did in a relation. We are actually connecting the points because we are graphing functions. So we're going to make an x and y table, x and y. Right? So we have our x, what we're going to put in the center, what our equation is, or what our function is. And then we're going to evaluate it for a couple different x's so we can get a good guesstimate on what our graph is going to look like. I'm going to use -2, 0, and 2. You always want to use a negative, 0, and a positive. And the reason I use -2 and +2 is because I'm going to be taking a half of x. So I want to make that easy as possible for me. So 1, -1/2, -2 plus 3. A -1/2 is 1 plus 3, or a -1/2 times a -2 is a +1 plus 3 is 4. Plug in 0, anything times 0 is 0, plus 3 is 3. And then we'll plug in 2, -1/2 times 2 plus 3, -1 plus 3 is 2. So now it's given me a couple points. I have -2, 4, 0, 3, and 2, 2. So I'm going to go ahead and I'm going to plot these points. Negative 2, 4, 1, 2, 3, 4, 0, 3, and 2, 2. And since I have a function, I'm going to connect it. Lines go on forever, so we got to put those arrows on the end. All right, again, try number 12 for homework, and we'll check it next class. Kind of in the white space on the bottom, I want to make a couple notes because there are 4 basic function types. Sometimes you will hear families. They're function families. So the one that we're going to be dealing with a lot right now is going to be linear. And this should tell you right in the name, it says line. This is a straight line. So any function that's linear, when graphed, is a straight line. The next one is going to be parabolic. These are going to be U-shaped. It may look like this, or if the leading term is negative, it's going to be down like this. We will discuss briefly this year absolute value. And these are going to be V-shaped. And again, it could be this way or this way. And the final one is exponential. And exponential graphs are curved. And they usually start off slow, and then make a dramatic turn. Okay, so these are your 4 basic types of function families or function types that we will be doing this year. We're going to do a lot with linear, a decent amount with parabolic, and then absolute value and exponential. We just mostly have to know what the basic shape is. All right, so towards the back, or the last page, example 5, we're going to use the function f of x to the right. So we're going to use this graph to find these things, to find f of 4. Well, what that means is we want to go take the function and we want to see what it's equal to when x, right, because usually x is in here, x is equal to 4. Well, I'm going to go over here to x equals 4, and I'm going to go down. Well, where am I? What is my output? Negative 1. Okay, so it's giving you the input, it's giving you the x, you're giving it the output. Again, 2, 3, and 4, or 2, 3 are going to be for you to do, but I'm going to do number 4. So now it's giving us the output. It's saying find x when the value of the function, or f of x, is 3. So we need to go, it's giving us the output, so we're going to go up to 3, and we're going to see where the function is. Okay, so that's negative 4. And again, finish 2, 3, and 5. All right, so with example 6, it just wants you to plot the following points. Well, this should be easy. We've been doing this. We know that this is our input, or our x, and that this is our output. So we just have to, this would be negative 5, 2. So I'm going to go to my graph. I'm going to go to negative 5. And then I'm going to go up 2. So it just wants you to plot those points. You can do 2 through 5. All right, final thing we're going to talk about today is evaluating the following expressions given the function. So here it's giving you 2 functions, g of x and h of x. Again, I don't know if I mentioned this before, but it doesn't necessarily have to use the variable f. It could use any variable. So it could be a function in terms of g of x or a function of h of x. So number A, so letter A wants us to find x if g of x is equal to 9. So we're going to go to g of x and we're going to use this function because it's telling us that right here. So it's saying that this g of x is equal to 9. So 9 is equal to 4x minus 7. And we're just going to solve this for x. So I'm going to add 7 to both sides. 16 is equal to 4x, divide by 4, and divide by 4. So x is equal to 4. And that's all you have to do. You just have to go to the right function and solve for x, because it's telling us to find x if the output is 9. All right, see? Now we're using h of x. So we're going to go use this equation right, or this function right here. H of x is equal to 1/4 x plus 3. Well, it's already telling us that h of x is equal to 0. So 0 is equal to 1/4 x plus 3. We're going to subtract 3 from both sides. Negative 3 equals 1/4 x. We got to multiply by 4. Negative 12 equals x. So we just found x if h of x is equal to 0. All right, your job to finish off the rest, and I'll be checking it next day in class.